All right, ladies and gentlemen, welcome. I hope you can all hear me. Just a reminder that next week today during um, this class session, you'll be having your semester test one, and it's a theory test, and it'll be very similar to the past papers that you've done, perhaps a little bit more applied, but the past papers are being worked through in the tutorial sessions, including today and the remaining tutorial sessions during this week. And we'll do different ones in each session. And then we will also take a look at, you also have access to all the past papers going back to, I don't know, 2010 or something, a long time ago, to work through online. You've had them for a while, so work through them in reverse chronological order. The ones that are closer to the present day and time will be better guides for you than the ones that are further away in time. But you'll see that it's pretty standardized, so you should be okay. Just please practice so that you can do as well as possible. All right, so let's continue with our work. So we'll be looking now at functions. We've already been using functions, but this will be just the theory that covers it. At some point, the theory will catch up with the tutorials. There'll be no new theory that we will cover, and then we will just do past papers and past exams for the second semester test and exam as revision until we're finished. So hopefully we can squeeze in a fair amount of revision for the practicals as well. But remember, you also have access to the VPL system, which you should be using to practice as well. All right, let's continue. All right, so functions, as we've learned, it's a different way of doing flow control to if statements and the loops that we looked at. So we will be making use of functions to modularize our code, basically to break it up into small little chunks that can be reused. Because the idea in software engineering, as opposed to just computer science, is you should reduce your code bases to well-tested, reusable, understandable modules and chunks, in the same way that an engineer doesn't have to invent a slightly different screw for every place that needs a screw, or a slightly different bolt for everything that needs a bolt, or a slightly different join, or whatever else it is that physical engineers do. Those parts are standardized and can be reused and are well understood. In the same way, programs should be broken up into a bunch of easy to understand functions with well-defined behaviors that can be reused as needed, and then they're packaged into libraries of these reusable functions so that you don't have to reinvent the wheel every single time. You, of course, as students, do need to at least understand how the metaphorical wheels work, so it's good that you build a working wheel at least once of each kind of wheel that exists. But in practice, when you're actually implementing software for a living, you won't be writing very low-level functions to do output or convert numbers or anything like that. You'll be relying on work done previously either by you or other programmers. So there are a variety of different kinds of functions, and they can be used in interesting ways in C++. We've already seen void functions used quite a bit, which we execute them so that they have some kind of a side effect in the environment. For example, performing input or output, those are side effects. There's changes to the real world when output is executed. So they're not executed typically to calculate a particular value that we want to know. They're executed because we want to do something. Although, as we have seen, and we will revisit in the tutorial, we have seen in the tutorials and we'll revisit in these slides, the parameters, if they are reference parameters, can be used to quote unquote return multiple values. So you can sometimes use void functions to get multiple answers instead of just one. It's typically not actually the most common use of void functions. In general, they're executed to do something rather than find out a value. We will see how we can have a bunch of functions with the same name but differing parameter lists, so that we can do the same thing with slightly different sets of data or in slightly different contexts. That's called function overloading. We will see that it is possible to have functions with an arbitrary number of parameters, but it's not really something you'll want to overuse. There's an easy, dangerous way of doing it and a safe, limited way of doing it. And in practice, it's not the best way of getting variable length inputs into your functions anyway. But we will take a look at what they call variadic functions. And then a very powerful technique that is actually used fairly often, you'll use it a lot in Computer Science 3 when you do data structures that are self-similar, such as trees. It's used a very great deal in the functional programming style of functions, of programming, and that's the recursive functions that are defined in terms of themselves. We've seen these before in code examples that we've done, but if you want code that executes at compile time as opposed to when the program's actually running, you can make it a constant expression instead of just a regular const, and that will help make functions that are fast. Calculate values that won't change during the life of your program. So there's no need to calculate them every single time your program is run, but they can be calculated just once at compile time and then stay constant at that point afterwards. We will also see lambda expressions, which are one of the, quite a few constant expressions and lambda expressions are part of what we call modern C++. And lambda expressions are basically functions that don't have a name, anonymous functions, which are also increasingly used. They came from the functional programming style of programming and have sort of made their way into mainstream programming. So we will teach those to you as well. For what it's worth, the modern C++ techniques that we teach you are worth bonus marks in the second semester test and exam. So none of that is required, but it is a way to boost your mark if you want to do that. So technically you don't need them. Obviously C++ programming existed long before modern C++, but it is a useful set of tools to have access to. All right, so let's take a look at functions. Functions are basically a named unit of reusable functionality. Other programming languages sometimes differentiate between functions and procedures, with functions being things that calculate a value and procedures being units of functionality that do something for a side effect, like also known as subroutines, for example, in languages like the BASIC family of languages, or just subs. But C++ doesn't differentiate between them. They're all functions as far as C++ is concerned. It's just some functions have a void return type, as in they return nothing, and others have some other data type as their return type. So in C++, we just call everything a function. So to declare a function, we need to specify its return type, give the function a meaningful name. It's the same rules for identifiers that you've seen in all your other functions and all your other identifier rules. So you name them the same way you'd name variables. Basically, when we start with the lower, except there's no need for a type prefix because there's already a return type. And then you have a formal list of parameters. Now the formal list of parameters can be, let's see if I can move this. Yeah. Sorry, it was just being blocked. The formal list of parameters can be just the types, or it can be the type and the name of the parameter. Typically, we will use the second style where it's the type and the name of the parameter, because that little bit of extra information you get from naming the parameter is useful information. So there's no need to throw it away. But technically, this is all you need to create what's called a function prototype, which is the definition of the function. Oh, sorry, the declaration of the function. Yeah, okay, we can zoom, but mostly, no, sorry, not zoom, magnifier. So you can see that this is the name of the function. It's called average. Take in 2 integers as input and give us back a real number as output. Or we could specify it more completely and say that it is called average, takes in 2 integers called int a and int b, and returns a double as its return type. And pretty much always I favor including the names of the functions. You'll see you need to include the names of the parameters. You need to include them when you actually implement the function, but you don't need to name them if you're just creating what's called a function prototype, which is basically a promise that you're going to create a function, in this case called average, that takes in 2 integers and returns a double. Okay, I see more questions, so let me zoom out. Okay, there's stuff on Discord, but that's not in the main channel. And let's go back. What's the functional difference between them? Great question. This one is the first one is slightly less useful because you couldn't actually create the function properly using it, because you have to give the names to the parameters for the code to be meaningful. So this style is used sometimes when you just need to create a what they call a prototype for a function. It is just a promise that the function will exist, whereas this can be used to create a prototype for the function and to actually implement the function. So in practice, we will just use the second style pretty much always. But I just want you to know that both are possible. Okay, so you'll be zooming yourself from now on. That's fine. Yes, in fact, the idea of class interfaces evolved from this, so absolutely correct. We'll be doing class interfaces in the second semester, but it's the same idea except at the function level, so 100% perfect. It hasn't been uploaded yet. I actually should have. I forgot to. Thanks for reminding me. I'll upload them straight after the class. Thanks a lot. All right, let me Don't worry about what a class interface is. You'll learn about that in Computer Science 1B. And then you wouldn't ever actually assign the names to the variables for the first one. You'd have 2 copies of the function, of the prototype. You'd have one of the signature of the function. You'd have one where you just need to put it to make the compiler happy, and you'd have the second one when you actually fully implement the function. So in practice, you don't need to use this one, this style, much at all. But if you ever do see it in the wild, I don't want you to suddenly be confused where are the function names. Where are the parameter names. It is a valid style. All right. Ugh. Let's get rid of that. Okay, so there's basically, in C++, there's 2 concepts. There's the concept of declaring something and the concept of defining something. Declaring something is where you basically make a promise to the compiler that the thing will exist at some point. And defining it is where you provide the full implementation details. So this previous step here was declaring the function, saying I will provide a function called average that will take in 2 integers and give me back a double. At some point before the compile is finished, before the compiler reaches the end of all of your code, you must have honored that promise by creating an actual function that matches that prototype, it's called. So here is the actual implementation of the function, its definition, where the 2 integers are added together and divided by 2. And in the definition of the function, you always have to include the names of the parameters because you're going to use them in the code in order to create the implementation. And you can sort of treat the parameters as being like local variables within the function. So it's that's why you typically won't see that first style, at least by us, much, because it just contains less information. Prototypes may as well include as much information as possible. So we'll take a look at what the purposes of just declaring it's in a moment. So I'll show you 3 examples. Very good question. No, if you've just logged in, even for a moment, you will be on our list. That isn't an invitation to just log in and log out, but yeah, please. If you return, your answer would be an integer. Let's take a look. No, it won't be an integer because look at what's going to happen. Integer plus integer gives us integer. Integer divided by a real number gives us a real number. So the overall result will be real. That 0.0 over there means the final type is going to be a... So the first style is just for declaration. Perfectly correct. Absolutely right. 100%. Okay, let's carry on. So you've seen it already in many examples. So here's just a silly example, printing to the screen. That's a function being declared as void with no return type and a regular parameter. And you see it doesn't calculate an answer for us, We simply use it to create an effect in the environment being, for example, the terminal output or something like that. And then you can see the use of the function, which is called invoking or calling the function, where you basically just have the function's name and actual values for the parameters. Not, so it could be variables that store the values, or it could be literal values themselves, like you see here in that example. Technically and strictly speaking, you can use the return statement in a void function. So you've seen return in main, and you've seen it in our examples with value returning functions. Technically, it can be used in a regular void function, and what it basically just does is it stops the function straight away. So you don't return any particular value, you simply say return, and the function stops. So this is a printing function where we're going to print values in a range from some start value to some stop value, but obviously it doesn't make sense if the start value is less than the stop value, so we end the function early with that return. It's not actually something you, again, see all that often, but it is possible to do that, so we give it to you. Oh, okay. So is there a scope for the semester's one? Yes, this is a clear sign that you're not fully participating in the course. There has been a scope for a while now. You've also got all the past papers, but if you log on, you will see under notices, semester test 1 scope, as well as the links to the revision videos that we've covered so far. So yes, you've seen that already. Let's continue. Okay, so break doesn't really quite have the right meaning in a function, but it's a really good question, because if you said break in this context, it would try and end the current loop. And you see there's no loop at that point. And if you put the break inside the loop, it would just stop the loop. Of course, there's nothing after the loop in this function, so the function would end. So it might look like it's working, but it's not actually ending the entire function. So return will end the entire function, sort of the strongest ways you could stop a function. So it's a good question, and the answer is no, not because break will stop the current loop or case in a switch statement. It's not going to stop a function. Good question, though. In a void function, when you do use a return statement, no, so you don't actually say return anything, because return 0, and I think you've got it because the second sentence there basically says you do understand. You see, we don't say return 0, we just say, why do I keep opening this? We just say return semicolon straight away. There's no value to return. So very good questions. It's kind of like an exit command, but just remember exit's going to end the entire program. So it's sort of, if you look at it in terms of levels of like impact, exit is the big nuclear bomb going off that kills the entire program. Return is like a, I don't know, conventional bomb. It will take out the entire city block, for example. It's going to just end the current function, and break is like a small explosion going off. It just ends the current loop. How does k++ affect the results? Remember, we use that for loops to move forward. So this is going to change the value of k so that it's 1 greater each turn. So k will go from whatever start was to 1 plus start to 2 plus start to 3 plus start to 4 plus start. If you're confused about that, please review the work we've done with for loops already. Can you call in a void function? You can technically. It's a weird thing to do. You can call main from another function because main main is just a function that starts first. And technically, you could run main from any other function. It would be super weird to do that. Don't do it. But technically, nothing would stop you from doing it. But good question. Yep, they're in the scope. You should be doing them. Okay, so continuing. Right, from current slide. All right, value returning functions. How do we recognize a value returning function? Instead of void, it's got one of the data types that C++ understands as its return type before the name of the function. So for example, main is actually a value returning function, as you've seen. It returns a status code saying whether the program exited successfully, i.e. 0, or any other non-zero value to represent a set of different error states the program could be in. This function here is a function called maximum, which clearly returns the greater of these two values, int a or int b. And because they're integers and we want the return value to be an integer, we see that that return type is integer. So here we have int a being compared to int b and being assigned to int max if it is larger, otherwise int b is assigned, and then we return int max. Some styles of programming say that you should try, wherever possible, to have only one return function, one return statement. You can have as many returns as you need in a program, because they say it makes the complexity of understanding the algorithm much greater if there's multiple returns. In general, I think if you can easily have a single return, that's probably for the best. But there are some situations where multiple returns just make the code much easier to read. And we will encounter some of those examples when we do past papers for semester test 2 and the exam, which I definitely find are much easier if you have multiple returns. So it's a good rule of thumb to have one return, but you can do other things. And then somewhere in main, this last line of code is where int best is being assigned the maximum of, well, in this case, 0 or 100, so it'll take on the value of 100. Once that value is in int best, you can do whatever you want with it. Basically, the value returning function call expression gets replaced with whatever the return value is. So whatever is in int max there, that replaces maximum being called on 0 and 100. Yeah, so for min, you would just need to flip the sign around and remove the, well, the equals doesn't really matter since you'd need to come up with a rule for how you handle equals. So it doesn't really matter. They'll both be the same value. So yes, you just flip the sign around, the comparison around. If the return type of a function is int, but the result is double. So this is a very excellent question. If the return type of a function is integer and we return a double, that will raise an error. The compiler will not be happy with that. However, if we return if the function expects to return a double and we return an integer, that is okay. You might get a warning, but the program will still work fine. And the reason for that is every integer is a valid double in a sense. Well, no, every integer is a real number, but not every real number is an integer. So the set of real numbers is infinite, and the set of integers is also infinite. But the set of integers is a smaller infinity than the set of real numbers, because between any two integers, there's an infinite number of real numbers squeezed in there. Obviously, computers can't represent infinite values, so there are some numbers that are too small to represent. That's called underflow. But the basic premise is still the same as in mathematics. Every integer can be mapped onto a double, but not every double can be mapped onto an integer. So returning an integer when the program expects a double isn't a game-breaking error. It's going to maybe raise a warning flag, but it's otherwise fine. So you won't lose any information. That's a great question. How would min-max in the context of an array work? We'll definitely do examples of that when we do worked examples. So in C++, a subroutine is a void function. We just call it by a different name. So yes, there are subroutines in C++, but there's no subroutine keyword. There's like in Visual Basic, there's no keyword sub, because all a subroutine is a void function. So excellent question as well. If main is a function, then why doesn't it have to be invoked? This is also an excellent question. It is invoked. It's just invoked by the runtime environment to start your program. So main is what's called the entry point to your program, because basically a program can be looked at as just a collection of functions. One of those functions has to run first. Which one? Well, the convention is to name the function that runs first main and give it a return type of int. And as you'll see later, either no or 3 parameters. And if it can find a function in the set of functions that meets those criteria, it will run that function. So we don't run it, so the runtime environment does. Very, very good question. So yeah, I think if this is related to the double integer thing, I think I've answered that. All right, let's continue. Oh, good grief. There you go. All right, from currency. All right, so modern C++. So in 2011, there was a change to the C++ standard, which was pretty important. It sort of marks the boundary between sort of traditional C++ and what they call modern C++. Modern C++, it has a lot more like things it can do than regular C++. But you can still solve any problem that can be solved using regular C++. So we don't require, the job of this course is just to teach you how to program, not to teach you every corner of C++. I can promise you there are people who are professional C++ programmers who are very good who do not know every corner of C++. It's too big a language for most people to keep in their minds at all time. Most people in practice use a small subset of C++. But there was an interesting boundary in the standard between C++ before C++11 and after C++11. C++11 was probably the biggest change to the language that happened, and a lot of modern features were introduced. One of these, and we just show it to you so that you have knowledge of it, is called the trailing type syntax. So in regular functions, you can see the return type comes before the function name. In trailing type, it comes afterwards, like some other programming languages that you might have seen. Pascal, for example, has the type afterwards. So the trailing type syntax allows you to do that. You put auto in front of the function's name, and then you can leave the keyword or move the return type to the end with an arrow like that. Is that necessary? No, it's not necessary at all. It's just if you ever see code like this, then you know what that means. Now, C++'s type system in the modern C++ versions is a lot more powerful than it used to be. So you can do some compile time reasoning about the types of variables. So one of the easiest things to understand about type inference is the auto keyword, which I have shown in some code that I demoed at some point this to you guys. I just can't remember when exactly. But basically the auto keyword will let C++ work out what the type of a variable should be based on the value going into it. It stays that type permanently there afterwards. It doesn't change afterwards, but you as the programmer don't have to specify it. So over here, A will probably be integer, but it could also be short or long or anything else that's compatible with 5. That's also one of the dangers of this style of programming, is that it's less descriptive because you don't know what the type is necessarily going to be unless you fully understand how the compiler works out types. So we will favor a style where you manifestly define the types. That's where you don't let the compiler work it out. So that's the auto keyword. There's been a couple of questions, so before I move on, I'll just try and answer them. It's just the syntax. Okay, let me just go. We haven't done that yet, so don't worry. Okay. Convert it, main, it's just the function, it's just the first function to be run in the program. Other functions get called from main. Main could technically be called from another function, don't do it. Okay, so that weird arrow operator is just the new syntax for trailing type functions, just so that it knows that this function is in the new style. So it knows to look for the type afterwards. This operator doesn't really have any meaning in this context. You'll see it being used when we do structures and pointers later on, but it's actually a different context. Here it's simply for the compiler to know what kind of function this is. So there is an arrow operator that exists. It exists, as I say, when you're using structures and pointers together, or objects and pointers, but this actually isn't that. It's just the same symbols being used. And all that it's saying is that this is the new trailing type syntax. So a good question. Yeah, I think I've answered that. So we haven't done that yet. We hadn't gotten there. Yeah, perfect. You've got it. It's not the same as the arrow operator that you will see in this semester, and definitely in the second semester. So it's just the same symbols were used. Was that a good idea? That's a good question, but it is what it is. All right. So moving on, what does decal type mean? Now, decal type lets you do reasoning on the types that already exist. So here what we're saying is we want to create a variable called B that has whatever type A has, and we don't need to want to specify exactly what that type is. So here we're saying let the type of A be worked out automatically by the type of the expression on the right hand side. That's 5. So it'll probably be integer, but it could be short, it could be long. We're not sure, doesn't matter, but we want to write some code that's compatible with it. So we say create a new variable B that has whatever type A had. So that's what decal type means. It means take the type or that was declared for a particular expression. And you can combine that with the trailing type syntax to do something weird like this, saying here we're creating a function which takes an integer and a double as its inputs, and its return type must be whatever the type was for x, which in that case was integer. Do you need to do this in your semester tests and even in your practical assignments? The answer is no, you absolutely do not have to do this. This is the in-depth discussion of functions. So if the stuff we do in the tutorials, that's the level you need to be able to actually code in. But this is a more detailed discussion for those who are more interested in what else is going. So it's sort of the opposite of auto. Oh no, yeah, it's not the opposite. It's sort of in a chain of type inference. Auto looks at an expression and works out what the type needs to be from that expression. Decal type looks at an already existing thing that has a type and says, take that type, copy it. So it's a very good question. It'll be evaluated by the type engine. So it's not going to be run like code would be run. But while the compiler is compiling your code, it will then look at what the type inference engine had worked out as the type for A in that case, and copy that type across. So can you use these for conversion errors? Basically, the answer is no, because conversion errors happen at runtime. Based on what a user actually types into the keyboard will be whether or not that the value is correct. All of this logic, all of the type inference and things like that must happen at compile time only. So there's no way to use auto to work out the type of something that comes in that you don't know the type of. Then you'd have to pick something like string or whatever that will store anything from the keyboard. But all of these things have to be worked out at compile time. A will need to be figured out its type. B via A will need to be figured out. And in this case, the return type of fun will be integer always because it's simply copying that type from X. So don't worry about this too much if it seems a little bit confusing. This is just, as I said, in-depth information for people who want to go deeper. Yeah, so this you see, now this is quite a tricky question because it may or may not compile depending on whether foo is a compile time function or not. If it's something whose type's unknown, let's think about that. Could that ever be a situation? It might work. Because the only time you'd have a problem with something whose type is unknown is if you're loading it dynamically, which we'll only take a look at in the second semester. So this will probably mostly be okay. But don't worry too much about it. It's about going into too much detail for it. Let's continue. All right. So when you want to use a function and you pass a parameter to it, you pass an argument to it, there's two ways to do it. You can pass those arguments by value, which means a copy of the value is sent along, which means that any changes that occur inside the function are not permanent. So for example, if we look at this code, there's nothing special about that parameter. It's just integer int param. And what we do is we simply output the value, we change it to 42, and we output it again. But then somewhere later, maybe in main, we set it initially to 1337, or a variable called int value. We then outputs that value. It'll be 1337. We then pass it by value. What we're going to get is 1337 over here. It'll change to 42. We get 42 as our answer, but then it will go back to being 1337. The change is not permanent outside of that function because this is a value parameter. Value parameters are copies of the value that gets sent. Whereas alternatively, what you can do is you can pass things by reference, by putting an ampersand by the parameter type. What this means is that the value isn't copied. The actual place in memory where the value is sitting is what's sent to the function. So any changes to int A and int B will be permanent outside of the function. They're not going to go back to their old values once the function ends. So if I sent int X to be 42 and int Y to be 1337, and then I called swap values, int X will now have 1337 in it, and int Y will have 42 in it. So those two values will be inverted permanent, well, and you can always change them afterwards, but the effect of the function exists after the function has finished executing. And something that's done very commonly is you don't often want the full copy of a value to be sent to a function. So let's take a look at a string, for example. A string contains potentially infinitely many, or well, it's not going to be infinite, but a very large number of characters in it. If we called a function that had a string as its parameter, a whole copy of that value is going to be sent to the function. So let's say that you had 100 gigabytes of memory. That's a lot, but let's say you had it, and that your string took up 500 gigabytes of memory, which is also a great deal of memory. But and you called the function. The memory would need to be duplicated. A whole extra 500 gigabytes, whatever I said, would have to be used up to make a copy of that string to send it to the function. That will mean you'll run out of memory. So what you could do is you could send a reference parameter instead, which would work fine because then only a small amount of information is being sent, namely where in memory is the string. But then you could accidentally change the string in your code and break it, right? Which you might not want to do. So you can combine the best of both worlds. You can have the permanence of a value parameter, but the efficiency of a string for a potentially very big container like the efficiency of a reference parameter, but the safety of a value parameter by having const and a reference parameter together. And you'll see that is done fairly commonly with containers like strings that can be arbitrarily big. However, modern C++ is actually super efficient at working out wherever there's an unnecessary copy and replacing it with a move, right? So 99% of the time these days, you actually don't need to do this. It will figure it out for you. But if you want to be sure, that is an option. I heard there were a couple of questions, so I'm going to go back to the parameter list. Okay, so conversion. Can I use C++ code to code Android apps? Typically not. Android apps run on what's known as the Java virtual machine. So you'll use either, well, it's the Delvik machine or something like that. It's the Android version of the Java virtual machine, but you'll typically program those in Java or related languages like Kotlin. There's a bunch of things that can compile to JVM code now. So typically not. I mean, technically anything's possible, but C++ code is typically considered unsafe because it can circumvent the security protocols. So typically you wouldn't. So there is it is possible, as the next person said, but I'm going to tell you in reality typically it's not common. Typically you will have something that compiles down to the virtual machine that runs on Java, on Android. You'll do JVM related stuff in the computer science too. So by value means a copy. Think of printing out a copy of a digital document. You can burn that copy all you want. It's not going to corrupt the file of your original digital document. However, if you accidentally, let's say, are working with your digital document and you don't have any backup system in place, and you move your document to a different folder and then delete that folder, well, then your document's gone. So think of it like the difference between if you're using files, the difference between copy paste, that's a pass by value, and the difference between moving, literally moving the file, that's pass by reference. Okay, so this is a great. Arrays and memory addresses are actually super closely related. So we will discuss those in more depth, but arrays are technically a combination of pass by value and memory addresses. With an array, the memory address is passed by value. So you can't replace the array with a whole new allocated block of memory, but it's a memory address. So you can change the contents of the array as much as you want, and those changes will be permanent. So it's a combination of the two. It's a constant memory address, but it's a memory address that will let you change things. So think of it like this. If you want to go to someone's house, right, and they owe you money and you want to get that money from them and you're going to like beat them up or something. If you go to their address and you beat them up, those changes are permanent, right? Those bruises are real. And if the address was written on unbreakable diamond, it doesn't matter whether you can change the address that's on that piece of paper. You've still gone to that place and made permanent changes. Pass by reference and pass by value done and void. So you can use both of them in any kind of function, but typically you'll see pass by reference used a lot with void functions to get quote unquote multiple returns. Typically, kind of, don't worry about it. So so don't worry about that. There are implementations of blockchains with C++, but you could use any programming language to do it. Can I use another function as a parameter of a function? Yes, we will do that. And return types, kind of. So we will do both of those. Is it possible by any chance to post the lecture slides ahead? Normally I do. Today I just I didn't. So normally I do, but mostly this is the one time that I've forgotten, unless I've forgotten other times. But I do intend to. So thank you for reminding me. I will definitely make sure to endeavor to post them. I can't post the next slide because we update these as we go along. So we need to adjust them based on where we are, what's in the pracs, things like that. So unfortunately not, but I could post them and then just bear in mind that they change. They could change. So we'll see. So I'll post these slides and think about posting the next set of slides as well. You do have the textbook as well, presumably. All right. Tell you what, I'll post both of them, this slide and the next set of slides. All right. Okay. So we don't have. I think we're kind of technically at the end, but let's go a little bit further because well, there's the tutorial next. So let's just do one more slide and see where we get to. Okay, this isn't too complicated. So when you call a function, you specify the values for the parameters. For example, in this case, there's a string message and it's being printed. It's a version of this function we saw earlier, presumably. There, print to screen, for example, with string output. But what if you wanted to create a default, as in, if I don't specify anything, what will the value of string output be? That's what this particular function does. It's got a default value for string message called hello. So if I call it without specifying anything, you get hello being printed out. But if you do specify something out, it'll print that instead. So that just provides a little bit of flexibility as to how your functions work. All right, let's answer a few more questions, and then I think we're done. So for practical 4 is that's the one on arrays and stuff. I did arrays, and there's a special lecture that's been posted for that. So if you take a look at the course content right there, 1D arrays, libraries, and namespaces, this contains what you need for practical 4. So it's a special lecture that was included, I think, in the instructions for the practical, but it's over there. You can get it from the list. So the next set of tasks will be available on Friday. So they'll be available for that set of so they'll be released on Friday. It's a good question. So if I put ampersand at the string, what happens? So I think if you mean the string variable, if we looked at the previous set of slides, oopsie, that should not have been shrunk. It means that the effect is permanent. So here, well, it actually means that the memory address is passed. So if there's no const and an ampersand, then the string is changeable. Basically, changes to the string are permanent outside of the function. And if I combine it with a const, then it isn't. It's functionally equivalent or usage equivalent to passing it by value. It's just more efficient from a memory usage point of view. All right, let's see if there's anything else. Contact sessions, that's up to the pandemic. We can't promise anything in that regard. So contact sessions will exist when the government and university administration says that it's safe. There's no way for me to speculate on that. Oh, but yeah, so this is a good question. If we go back to contact, I see what you're actually asking. If we go back to contact sessions, we will still record them and post them online. So yeah, no. So we'll keep the best of both worlds. We'll have recordings and live lectures when we go back one day, hopefully. Is copying a variable the same as copying a memory address? No. If it's by value, the content is duplicated and sent somewhere. If it's by memory address, then where it is in memory is sent. If I put ampersand on the last slide of the lecture, we were over here. If I put an ampersand where, I'm not sure I understand. So you might have to ask that question in the Discord server with an example. So the print function in this case will send this message to the output stream. That's all it does. But if you compare these two uses of it, one, I don't specify anything. What should it print? Well, we've provided a default value. It'll print hello then. But if we specify something else, it can print that instead. So this one will print hello, and this one will print Sawubona. On the string variable, so like you mean over there? Oh, you mean if you combine default values and reference parameters? But if you want to put a reference parameter, you can put it there. So again, it'll still be a reference parameter, but it'll be a reference parameter with the default value. So if we ran print there, it will shift over to being hello, and if we ran print there, it will shift over to being Sawubona. This will not work in this case because you can't replace this value with anything because it is what they call an L value. There's no variable associated with it. So there's no way to store a new value. So it'll be a little bit problematic in this particular case. It's actually quite an interesting question that you've asked, if I've understood you correctly. So is print the same as cout? We've just made a new function called print that will just use cout. This is just an example. Print isn't built into C++. We created it, but as an example about how to create functions. So there's not going to be a pop-up. There's no code related for anything to pop up. All that has going to happen is the string message is going to go to cout. So it does exactly the same thing because that's what we defined it to do. The code for understanding it is literally right there. Excellent question. Now, again, with all of the standards related stuff, and we're going to switch over to the tutorial in a moment now. So this is the last question I'm going to answer, but it's a good one. For standard sec, which should use out of the two? I personally prefer to put the type with the reference because it is a different kind of thing. It's an integer reference, not an integer. Whereas the other standard is to put it with the thing that's being declared. We'll do a more in-depth discussion of the pointer syntax when we go into memory in more detail, but I prefer this. Other people vehemently prefer that. If you're consistent, I don't mind. But this is the standard for our local standard. But we won't. You will never lose marks for doing that. So just bear that in mind. Foo is just as example. Yes. So we're switching over the tutorial now. Okay. All right. Goodbye. See those of you who are in the tutorial. Goodbye.